All right, and good evening, ladies and gentlemen, and welcome to the July Recreational Astronomy Night of the Toronto Centre of the Royal Astronomical Society of Canada. My name's Tom Luton. I'll be your host this evening. Tonight's presentations, we've got Claudio Oriani with The Sky This Month, Shraddha Pai with Moonbows and Milky Ways, my stargazing adventure in the rainforests of Kaua'i, and finishing up with Frank Dempsey and giving us an update on the variable star T Corona Borealis. And then we're going to have announcements done by myself because our president, Scott Masterton, is away. So without further ado, actually, one piece of ado. Is anyone here for the first time? Welcome. Round of applause, please. All right, so let's get the show going with Claudio Oriani and The Sky This Month.
Thank you, Tom, and hello, everyone. Happy July, and I'm here to talk about the sky for the month of July. So we have so many things happening. I don't want to waste more time about all the stuff, but I will talk about these pictures here for someone who asked before, and just stay tuned. Let's start. So what do we have in the sky for this month? Lots happening. So we are getting further away from the sun tomorrow with aphelion, and we don't really feel that it's colder. Actually, it's very hot. It's just a few million kilometers more than usual. We see the Summit Triangle stars. Oh, just a sec. The battery of the computer is getting low. That's not good. See, it's like the battery is not working. Yeah, the battery. Let's see. It's back. Technical problem, but we solved. And you see Vega, Altair, and Deneb high in the sky. This triangle of very bright stars. That means that it's summer, finally. If you're going away from the city, you see the Milky Way galactic core from the dark sky, Scorpius, with the red supergiant Antares. In a few million years, it will turn into supernova. We don't know yet when. And of course, looking at the teapot, the Sagittarius, so there are lots of narrowband targets, the Lagoon Trifid Nebula. If you remember the picture of the first slide, there were two of them, and I will go back. Venus is the brightest object in the sky, in the morning sky, followed by Jupiter. Finally, it's back in late July. Mercury reaches its greatest elongation on July the 4th, so it's visible very low in the sky after sunset. Better from the southern observers, but we can have a look at Mercury in the next few days. Mars is still visible at sunset in the western sky and sets before midnight red. You can't be wrong with Mars. Saturn is finally back and will rise before midnight later in July. Pluto will reach opposition on July 24. If you have a big telescope, you can maybe try to take images if you know where to look at, long exposure. And that's quite new because southern observers can now observe two novae simultaneously, and they're both visible to the unaided eye. I don't recollect that this never happened before. So we have a V variable 462 Lupi and variable 572 Velorum. They're both very low. So Velorum, forget about it. It's not visible from our latitude. The star in Lupi, it's technically possible, but it's very low to the horizon. We go back to that star later. And of course, I know Frank is talking about the Corona Borealis. Maybe you're going to have three naked eye novae. Let's see. And we also have a meteor shower, the Delta Aquarid meteor shower that peaks around July 29, 31st. So not one of the brightest, but you can have up to 20 meteors per hour. So let's talk about how many hours of darkness we have, a little bit only, because we have 15 hours of 22 minutes of daylight today, and August is not going to be much better. We have one more hour of observing night because we have 14 hours of daylight. That means that today we have only 3 hours and 58 minutes of imaging time. I did my homework. In August, we gain almost 2 hours darkness. It's never very dark for our latitudes, but you know that just 3 hours. It's getting dark around 11 p.m. And if you do astro images, you know what I mean. You have to be up late. Let's look at the sky. This is from Stellarium. And again, if you go in a location when you're dark sky, you can see the bright Milky Way, the south, 11:30 p.m. You see that there are the summer constellation. You can see Scorpio. You see Sagittarius. And Eagle, the Aquila, to the left. So that's the shape of the Milky Way, our galaxy. And if you look there, I was mentioning the nova in Lupi. So that's technically possible to see, but again, it's 6 degrees above the horizon at its maximum. It's there, where I put this square. So basically, that's where the star is located. So if you see Scorpio, we don't see, because this is much farther south, but this is where the nova was visible. And it was 6.3 degrees above the horizon. Magnitude was 5.6 on June 21st. I believe it's still above the naked eye visibility, but I'd say that's very, very difficult to see. You can try if you have a dark spot and a southern horizon that is free from trees and light pollution. You can try. If you look at northeast, you see the Aquila and getting higher, and also start looking Cassiopeia to the very left, and Pegasus is there. But there are so many narrowband targets visible there. I will go there later. You see Cepheus, Cygnus, and all these squares, the green squares on the image on the map, are narrowband targets. Northwest, you can see again Cepheus, and then the Ursa Major is still high in the sky. You can still see some of the beautiful galaxies there. And then looking southwest, tonight you see the moon, and Leo is setting now. Arcturus is still up high in the sky. If you look overhead, you have the opportunity to see lots of globular cluster. So Hercules, you have a M13, M92, all these yellow spots here. And Ophiuchus, also beautiful globular clusters. What about the sun? Again, we reach aphelion in July 3rd, 2025, so tomorrow. And this is a little bit farther than usual. Orbit of our planet is almost circular, so you don't really see the difference, but that's something interesting to see. Of course, the sun is moving along the ecliptic, passing through the zodiac constellation. Sun is in Gemini until July the 20th, and then is moving Cancer. We don't see from here because the sun is obviously bright, but just to know. And the maximum midday altitude for the month of July of the sun is almost 70 degrees above the horizon. I mentioned to the solar cycle number 25 has passed its peak, probably was last August. And while the overall activity is declining, there are still long-lasting coronal holes. That means that coronal mass ejection equals northern lights are still possible in the coming weeks or months. That's the distance tomorrow. See, the difference is like just a few million kilometers. Tomorrow is on that side. This is an image of the sun in hydrogen alpha. You can see beautiful prominences, sunspots. They're like inverted colors. Filaments, and that's the structure of the sun, with a small 40 millimeter telescope. What about the moon? So the moon will reach apogee to July 5th, 400,000 kilometers, and the perigee will be on July 20, 360 years. So 40,000 kilometer difference between the apogee and the perigee. So that means that you can see the moon getting a little bit bigger, a little bit dimmer in the sky if you know where to look. What about the phases? So the full moon, the back moon, is on July 10 at 4:37 Eastern time. I just learned the back moon is because the antlers are growing again this time of the year. Last quarter will be on July, I forgot the day, but there is 7 days after, July 17. New moon will be on July 24. So if you want to observe without the moon in the sky, write the date. And first quarter will be August 1st at 8:41. One more mention about the moon. Tomorrow night, there is a chance to see the lunar X. So there are just some visible features that will be lighted by the moon. You can see with a small telescope, a binocular, a crater that is making the X and more stuff happening. You can also see a LOVE, so love on the moon. Like Brescia, I always like to show this animation of the moon. That means that our tidal forces are just making the moon wobbling. So we see a little bit more than 50% of the moon because the tidal forces. We can see 59% of the moon. A little bit more on the north, the south, the east, and the west. And these are the opportunities to see pieces of the moon. They are not usually visible. So on July 8, you can see more of the northern part of the moon. On July 13, you can see more of the western limb of the moon, and so on. July 22nd, you see the southern part of the moon, the southern pole, and the eastern part will be more visible on July 27. There are so many things happening with the moon and planets and stars this month. So on July 16, the waning gibbous moon will be near Saturn before sunrise. July 21st, the crescent moon will be close to Venus. This is a beautiful opportunity to see both of this object. And on the July 23rd, Moon and Jupiter will be in conjunction before sunrise. While on July 28th, the crescent moon will be near Mars in Virgo, post-sunset. In detail, this is what you can see with the 135 millimeter lens on the DSLR camera. So you see on July 16, Moon and Saturn at 2:30 in the morning, not really easy for people that are going to sleep early, but you can see they're fitting very well. They're nice in the same field of view, 2:30 in the morning. Moon and Venus will be in the same area of the sky, not in the same field of view, but if you have a wide angle lens, you can see the moon, you can see Venus, and on the top you can see the Pleiades. That's a beautiful opportunity to see both more interesting objects together. From my experience, when the moon is very bright, it's very hard to find a balance to also capture dim objects like the Pleiades. I tried many times, it's not very successful, but if you can, maybe let me know. On the 23rd, the Moon and Jupiter before sunrise are together. You can see Jupiter is just popping up to the right of the Moon. The Moon is very, very slim. And Moon and Mars will be together at the end of July, on the 28th. That's so beautiful. Not only the planets, the Moon is also meeting some bright stars. Spica, tomorrow in Virgo. Antares in Scorpio on July 7. The Moon will occult the Pleiades, I mentioned before, and this is a good opportunity before sunrise on July 20. And on the 26th, Regulus and Moon will be very close. I can show something in a few seconds. Spica will be back in the same field of view of the moon on the 30th, and August 3rd, Antares will be again north of the moon. That means that the moon orbit is always meeting these bright stars, and sometimes in some places of the earth is also occulting them. Not here, except the Pleiades. So that's tomorrow. The moon and Spica, 10:30 p.m., so easy in the sky. Moon and Antares, they're very close together on July the 7th, 10:30, still prime night, prime time. And then that's one of the highlights. So on July 20, the moon and Pleiades are together, and actually the moon will occult the Pleiades. The moon is waning, so maybe the difference in brightness can make possible to take beautiful pictures. And look what happened on the 26th. Just after sunset, Moon and Regulus are close together. Look what happened during the day. They are close to the sun, so please look where you're pointing your binoculars, but they are so close, just very close, so there is no occultation from here. I'm sure in some part of the world there will be occultation, not here. They're just together. You take an image of the moon during the day, 5:55 p.m., maybe a long exposure with some trick with your camera. Maybe you can also see Regulus in daytime. Regulus is one of the brightest stars in the sky. And again, Moon and Spica on July 30, 10 p.m., they're close together. And again, Antares and the moon are together in the sky on August the 3rd. Let's go on the planet now. So Mercury is visible in the evening, the beginning of the month, and then will disappear because it will dim, it will be very low to the horizon, then disappearing, and then it's going again in conjunction. Venus is the brightest object in the morning sky, while Mars is still visible in Leo in the evening, but is getting dimmer and dimmer. July is also the month when Jupiter will be back in the morning sky. Saturn is a morning object, but by the second half of the month, it will be visible for the entire night, after midnight, and then before midnight. Keep an eye on Saturn, because I will go there very soon. There is something very unusual happening in the next few weeks. Uranus is not really visible. We have to wait probably the next couple of months. Neptune is also very close to Saturn, so they're in the same field of view. As I say, Mercury reaches the greatest eastern elongation, so visible the highest in the sky on July the 4th. It's very low in the western sky. After sunset, you can try to take some images of Mercury with some landscape object beginning of July, maybe close to the moon around the July 6th or 7th. And then it will disappear and go back in the morning sky in August. On July 4th, see Mercury and Mars, very, very interesting, but it's still very, very clear. So it's probably too bright, but you can try to spot them and maybe image them. That's Mercury, first red circle, and that's Mars, the second one. Venus. If you wake up in the morning before sunrise, you can get wrong. On the eastern sky, there is this bright object, and that's Venus, white, early morning twilight. On July 21st, the slender crescent moon passes close to Venus. It is perfect for a dramatic wide field composition. And then it's also near the Hyades and Pleiades later in the month. And the Pleiades will be the occultation, if you remember. This is Venus and the moon on the 21st. And if you remember, also show the Pleiades there. Venus and the moon. Mars is still visible in the evening sky. His brightness is only +1. It's still bright enough. It's past its prime time. It's well placed for imaging during the early night. If you have a telescope, you can also spot some details, but it's just 4 arc seconds So you can really see a little bit. On the 28th, the moon passes near Mars, if you remember the slides I showed before. And Mars and Regulus are always together, not too far away. Last month, they were very close for a few days. It was beautiful to see the movement of Mars during the day. Again, it's 4.6 arc seconds only. That means that you can only spot probably the northern cap, the polar cap, and some other details. Jupiter is returning, is -2 magnitude and still low in the morning twilight, but you can see the Galilean moon shadow transit occultations. I didn't want to bother you with all these details. If you have the observer handbooks, it is on page 2026, 2022, but there also the little round shadow of the moons passing in front of the planet. I also find interesting when the shadow of Jupiter is occulting the moon. You can see the moons in the sky around Jupiter, and then suddenly they disappear. That's dramatic. Even when this is happening, it's very interesting. I already told about the moon close to Jupiter on the 23rd. And Jupiter is also close to the Hyades cluster. You can try to take some wide field imaging. Saturn, I will spend more time on Saturn for a specific reason. So it will be higher in the sky until early September. We reach the opposition, and the rings will just moving on the other side because of the inclination of the orbit. So they technically disappear for a few days around the end of March, and now they're getting bigger because we are moving on the other side. On July 16, again, there is a waning moon very close to Saturn. And wait, did you know there is a Titan's shadow transit season? Every 13, 15 years, Saturn has a 27-degree axial tilt, and the Earth at 23.5 tilt. So combined, when they move in the sky, there's just like a meeting, and when they combine, the view of the rings is changing over time. That also means that for some months, around every 13 to 15 years, transit of a Titan shadow will pass over Saturn, and we can see from here every 16 days. This started in May, every 16 days. So there was another one last night. I would have loved to watch, but I had to present today, so I wanted to be awake. But the next one will be on July 18. This is universal time, so subtract 4. So 4 o'clock in the morning on July 18 until 9:44 is the maximum that transit. 9:44 is at 5:44 in the morning, and so on. And August 3rd, there is the next one. This is what happens on July 18 from Stellario. Can you see the, this is Titan. This is Saturn, the rings. Can you see the shadow of a Titan on the Saturn? Is there. This is Titan, this is the shadow. 3 o'clock in the morning. This is what happens at 5 o'clock in the morning. See this? And by the way, Titan is the second biggest moon in the solar system and the only one with a thick atmosphere. So you can see the round shadow of the Titan on Saturn. This is kind of unusual. Other moons are always passing in front of Saturn, but they're too small to be really visible. And on August 3rd, again, it's a little bit early, so 2:25 a.m. Maybe I can try this one. When it starts, 4:52, the maximum, when you reach the meridian, and so on. Uranus, not much to say, 5.7 magnitude in Aries, is visible before dawn, but it's really, really dim. So we have to wait, probably next month will be much better. And in September, October will be very, very bright. Neptune. Neptune is sharing, by the way, the same portion of sky of Saturn, and you can imagine them together. They're big different magnitude, because if you remember, Saturn is a little bit more than +1, while Neptune is +7.8. But you can also see the yellowish color of Saturn and the blue color of Neptune together. The moon is going close, so maybe you can try to take an image, long exposure, and see if you can spot Neptune. I did during the lunar eclipse, I remember, and there was this blue disk, it was Neptune. Yeah, it can be interesting to find and follow the motion of Neptune with a big telescope. Look what happened on July 14. I mentioned Saturn and Neptune together in the sky, with 135 millimeters. By the way, they are in the same area of the sky for the entire month. So pick one day. In this case, it's July 14, but you can see Saturn move a little bit to the left, and they're like sharing the same area of the sky. Still, red square is a 135 millimeter field of view of a DSLR camera. Deep sky suggestion, my suggestion, but also Telescopius. This is a free online planning tool I'm always using to see which object high in the sky. And someone is asking why you're taking images of the Crescent Nebula. Because I look at Telescopius and other people observing, and my limited time, I can do this stuff. So Crescent Nebula, I took an image like 2 nights ago, I guess. M8, we have to wait a little bit later. In August will be even better. The problem with the M8 and M20 in Sagittarius are very low to the horizon. The signal loop is getting very high. This is one of the best targets you can try to image with a wide angle, because you can image the entire supernova remnant. Let's see the Crescent Nebula. Where is in the sky? This is the Cygnus, and this is the Crescent Nebula. And this is what you can see with, this was my telescope 2 nights ago. And that's just amazing. What is the Crescent Nebula, by the way? It'll be creepy when you see the image. So it's an emission nebula. It's 5,000 light years away. And the powerful stellar wind, that massive Wolf-Rayet star, WR 136, is a star that is just ascending, is a shock wave gas. They're just meeting the previous shock wave, and they're just making these waves in the sky. You can see like this star emitting these outer layers in slow motion. And it's so amazing that you can image them from the light polluted sky with a narrowband filter, because the narrowband filter is just removing the entire light pollution and is increasing the hydrogen alpha and the oxygen 3 light wave. If you have a mono camera, you can also try to use S2, sulfur 2, but that's too technical. I don't want to bother you too much. The Lagoon Nebula, so we will see a star that is towards the end of its life. The Lagoon Nebula is a stellar nursery. Where it is? In Sagittarius, near the center of our Milky Way, where the red circle is here. And this is what you can see with the narrowband filter, but it's also a broadband. You can see all these dark spots inside, these little globules. So these are all stellar nursery. The block, I can show you in a few seconds. The Bock globules. So just these globules that are, sorry, too fast. They're just places where the stars are getting born. And this is just something that you look there and then you know that in like 10,000, 100,000 years, there will be a new star there, another new star here. Just amazing. They're very, very beautiful. And in the nearby, there is also the M20, the Trifid Nebula, M20. So if you have a wide lens and a narrowband filter, you can take beautiful images of both the object, M8, the Lagoon, and M20, the Trifid Nebula. And then the Veil Nebula. We talk about the star that is dying. a place where stars are born. But what happens when a big star is exploding? Depending on the mass, it can turn into a red giant, then a white dwarf. Or if it's too big, it's turning into a supernova. And the supernova is just releasing all the gas in the sky. The Veil Nebula complex, also known as a Cygnus loop, is there, and this is what you can see. Eastern Veil Nebula, Western Veil Nebula, also known as witch broom. Again, is a supernova remnant. It's occupying 3 degrees in the sky. I also know that the people taking picture like 20 years, this you can see the nebula expanding still in the sky. This something happened 10,000 to 20,000 years ago. Unfortunately, we couldn't annotate yet, but for sure it was a very bright supernova. You can see the glowing gas, red and green, oxygen and hydrogen, that are just beautiful in the sky. Again, if you have a wide field set up, you can imagine the entire Cygnus loop. I was using a Rokinon 135, and I was able to take the entire supernova remnant. Almost there. Comets, asteroids, and minor planets. No major asteroid position. We are good. No bright comets. Not yet. I was reading it was a new object, interstellar object, just discovered a few days ago. They don't know yet if it's a comet or a planet. The name is so complicated, all letters, numbers, but if you look in the news, you can see. It will be safe distance beyond the orbit of Mars. Pluto will reach opposition July 25th, for those who want to consider Pluto still a planet, like me. Meteor showers, we have the Delta Aquarid. The end of July will be the best time, 29 and 30, around 5 p.m. So it's still early for us, with activity continuing strong into early morning. So that night can be a good night to spot some of the meteors. Not too many, 15 to 25, under optimal dark sky condition. You don't need any tool, just sit down, turn off your phone and look up in the sky. 2 a.m. will reach the maximum peak in altitude. Again, new moon will be on July 23rd, but on July 29 and 30, you have to wait until the moon is set after midnight. You can have some hours of good viewing. But we also have the Perseids. We know that Perseid will reach the maximum in August, but they are very, very active. And we can see that the active period is starting on July 17. So we can have more than 100 meteors per hour. This year, of course, there is a moon on the way. In July, we can see 5 to 15 meteors per hour, but it's very, very possible that you can see very bright fireballs. And around midnight, Perseus is high in the sky by 4 o'clock in the morning. Between July 25th and 31st, the moon will be out of the way, and you can hope to see some of them. International Space Station passes, and we are done. There are a few happening in July. There are almost everything happening during the night, 11:53 and 11:56. I highlighted the ones that are the best for us. So this is what you can see. I don't know if you can really read, I can't. But yeah, what you can see here is that it's passing almost overhead, and minus 3.6, minus 3.8 magnitude means that it's very bright. If you know where to point, even your telescope, you can try to imagine the shape of I never did it, but it's cool to try. And then this is happening again on the 22nd and 23rd. So that's the best one. July 24, the morning, 441 to 450. Maximum altitude will be on 444, and brightness will be minus 3.8. And with that, I think I'm done. Thank you so much.
Thank you very much, Claudio. Any questions from the audience?
For the Perseid occultation, sorry, yeah, the Perseid, not the Perseid, the Pleiades occultation.
Okay.
Now I got it. How many of the Pleiades are occulted? Is it just one or two, or a whole bunch?
It always depends on where you are located. So what I can say that is true for me, Richmond Hill, maybe it's not true for you that are in Toronto, because depending on where you're located, the angular position, the moon is close enough, and the Pleiades are like light years. The moon will pass through the Pleiades. It's not occulting all of them, but I expect at least 3 or 4 of them will be occulted by every area in the GTA.
Thank you for a nice talk, Claudio. For visual astronomy, with a small telescope, what filter would you recommend for Venus?
Oh, that's a great question. Depends what you want to see. I can tell that you can use some like moon filter to reduce the brightness of Venus. So you can just see the better contrast. But if you want to see the clouds, I know there are these UV filters. There is like a Venus UV. They're so expensive. This little piece of glass, like $500. And the great thing that you can see the clouds on Venus.
To actually see the phase, what would be the best color? For the phase, what would be the best color filter to use?
Probably a yellow filter can reduce the overall brightness. But again, you don't really need a filter. You can easily spot the phases even with binocular.
Thank you.
I have a random question, but do you know when the light from the Veil Nebula reached us?
Oh, I think it's 5,000 light years away. That means that the light we see now started 5,000 years ago. That means maybe it's not even there anymore. Probably it's still there, but right now we see how it was 5,000 years ago. There's a beautiful thing about the sky. So you look at Andromeda Galaxy, you look how it was 2 million years ago.
No, it's quite cool.
Yeah, it is.
That's how light years and physics works.
Yes. Thank you for this question.
Any other questions? No. All right, then. We're going to go quickly to fun facts while we switch over to... No. Quickly switch over to fun facts while we start our next presentation. All right, ladies and gentlemen, we're back. And our next speaker is Shraddha Pai, who's going to be talking about Milky Ways and Moonbows stargazing adventures in Kaua'i.
Thank you, Tom. I'm very excited to present tonight's topic because this was, a totally unexpected trip, so many riches of the natural world, both in terms of hiking and stargazing. And I know this is a great audience for this presentation. So to situate you, this talk is going to focus on some fun stargazing adventures in Kaua'i. And Kaua'i is located, it's part of the Hawaiian Islands. It is off in the Pacific Ocean here. You can see where it is relative to US and Canada, long flight to get there. For stargazing astronomy purposes, I just be aware it's 22 degrees north, and depending on what latitude you go to, you might have different objects visible in the night sky. The Milky Way may be in a different position as compared to what you expect to see in Toronto. And let's zoom in a little closer. So now we're looking at all the Hawaiian Islands, and you've got 4 major islands, and Kaua'i is here, and it's the northernmost island. Now, this is, these events sort of happened during a vacation that we took during March of 2025. And usually, if you are interested in astronomy and astrophotography, vacation planning and looking at your astro apps go very much hand in hand. So of course, I pulled up a light pollution map of Kaua'i. Original reason we're going to Kaua'i is because of the marvelous hiking, right? All the things you do during the day. But what about the opportunities for visual astronomy and astrophotography? So this is a light pollution map of Kaua'i, and there is a website online which is very handy, and they have an app. So if you ever want to know how dark a place is that you're going to and how clear the night sky is going to be, this is usually a good indicator, although this map is about 10 years old. And the way to read this is that, the more vivid these colors are, the more light pollution there is. So on the left, you have an image of Kaua'i, and on the right, you have an image of Toronto, which is down here. Here's Lake Ontario, and here is the edge of the lake, and here you've got Toronto. And for reference, here's Algonquin Park up here, right? So much of Kaua'i, according to this 2015 map, especially in the northwest area, is very dark. So Bortle 2 skies. It's similar to Algonquin Park. And you've got some urban centers scattered along the southern shore. Okay. The other thing you'll look at if you're going on vacation is the moon phase, right? So I have another app for that, PhotoPills. And the Toronto District School Board, in its wisdom, chooses to have March break around the full moon. This is not the first time this has happened. So of course I'm looking at this, and Claudio just told you about all the lovely things you can see if there's no moon, right? So this was what we were facing. The moon was only going to get fuller as we got there, and it starts waning a little bit, and the yellow rectangle shows when we were going to be in Kaua'i. And this is sort of where you have the full moon, right? So I'm optimistic anyway, because I know jet lag happens. You can wake up at really early morning and the moon's about to set and things like that. So I take some things within reason. This is a family trip. So I have my regular DSLR camera with wide field and zoom lens for daytime photography. Crucially, I take my tripod, because if you're going to do night photography, you're going to do long exposures, you're not going to be able to do this handheld, right? Even on the some new iPhone models, you can do 10 seconds handheld. So if you want to try to get the Milky Way in night mode on some phones, you can, 10 seconds. But if you have a little selfie stick or tripod, you can go up to 30 seconds. Lots of fun. Take a dew heater, because it gets cold and you get condensation on your lens and you need a little battery to power it. I take the smallest portable star tracker I can think of taking, my little Star Adventurer Pro, and never underestimate the phone camera. This time I had another little fun toy that I took with me. And this is one of these smart telescope gadgets called the C-Star S50. Lots of fun, very portable. I've taken it on other hiking trips like to Zion National Park in Utah and stuff like that. So this was my gear we went with, okay? So the way we did our trip was we started out in this northwest area. I mean, our vibe is for family vacations is more raw, the more sort of away from civilization, the kind of we're drawn to that, right? So we started in the northwest section here in Kaua'i State Park, which is a rainforested area, lots of beautiful flora and fauna, lots of vegetation with native birds and things like that, right? So let's see what happened when we went there. So here is a view from, you have to go up this sort of, you leave civilization behind, you have to pack your groceries when you go there. It's like a half hour back if you want to go get groceries. And you go up this kind of windy mountain road, and there are all these canyons from previous volcanic activity formed. And you go up this windy road, and at the top, you've got the cabins, you've got a lookout. And here at the lookout, you are seeing the famed Napali coast of Kaua'i, right? It's just a very, very iconic view for Kaua'i. And this is the view we've got there. So a little orientation to understand my adventure in Kaua'i State Park. So as I said, there was this main road, and we were staying in these cabins, which I really recommend if you're into this kind of thing. There's no Wi-Fi, there's no cell phone reception, very nice cabin, furnished kitchen and everything, right? So we were like, I don't know what's going to happen. We're going to be without a cell phone for 3 days. Let's see. And very close to the cabin, right, within like 2 minutes drive, was this big clearing where there was the Kaua'i Museum, where you have some sort of little mini dioramas of the flora and fauna of the space and so forth, some hiking trails. What's important to note for astronomy is that if you're going into a rainforest, you have a lot of trees, you have a lot of canopy. And so you're not going to be able to see the sky and the stars if you go into one of these places over here with all the trees. For better or for worse, this area was clear. So if I went here, I got a nice view, 180 degrees plus all around for me to go look at. This place was beautifully dark. This is a photo I took out of the front door of our cabin at night, and there were no other external light sources. Because we were in the rainforest, it was kind of drizzling on and off pretty much all the time. And much to my dismay, there were clouds blowing by all in the sky all the time. So here you are in a Bortle 2 location during a full moon with clouds blowing by and rain, right? Sounds awful. Anyway, thanks to jet lag, my eyes opened around 4 o'clock one morning. And I've learned from previous experience that when that happens, you try to stick your head out of wherever you're staying and you look at the sky and you see amazing things. And so I decided to make a little jaunt in our car. I didn't drive. I took the car and I decided to go to the viewing lot next door. So I left this little note. My family knows to expect us. I said 4:30 a.m. gone to Kaua'i Lodge parking lot to see the stars. Be back by dawn. Okay. Now, the one thing that's important to note from a safety perspective is because you have to consider which location I was in, right? So I was in Kaua'i. So I looked up what are the largest animals that I can expect when I'm out at night. And luckily, the answer seemed to be, the largest animal is some feral pigs that were brought to the island by Polynesian ancestors a long time ago, and now they have just gone wild. And then there are lots and lots of chickens, jungle fowl everywhere. I mean, in the city, in the rainforest, you name it. If you go to Kaua'i themed stores, they sell merch with chickens on them, like on hats and stuff. And the other best part was there were no mosquitoes. There were no biting insects, which was amazing. Yeah, right? Yeah. So off I went, got out of here, took the car and went down here. And when I got there, the museum porch light was on. I was like, oh, this is just insult, to injury. This is the vibe. This is the wild animals of Kaua'i for you at 4:30 in the morning, right? You do what you need to, right? I know. We were warned about that when we were looking at the TripAdvisor reviews. So I got out of my car. Oh, yeah, I have to say, one of the reasons I really want to get out at Bortle to Sky is because I wanted to see this phenomenon called the zodiacal light. It's this phenomenon where you see this kind of ghostly white triangular shape in the western horizon around sunset and the eastern horizon around sunrise. And you have to be in really dark skies to see it. And I needed it for my RASC imaging checklist, right? So I came here and I was like, I gotta try my luck, see zodiacal light. So I get out of the car in the parking lot and I look out and I see this, right? And I'm like, wow, it's zodiacal light. Or wait, is it, right? It looked really ghostly white to my eye, but it had this very distinctive arc-like shape, right? So I said, let's photograph it. This is my answer to everything, basically, right? So then what happened was I set my tripod up and then I took an image about 3.2 seconds and the camera saw what my eye couldn't. And that was that it was a rainbow. But it's a very unusual kind of rainbow because usually for rainbows, you need rainwater mist and you need sunlight, but the sun hadn't risen yet. In fact, the moon was right behind me. So this was not a rainbow. This was what I later came to know was a moonbow. At the time, I was like, oh, that's weird. This is just, it's just a rainbow at night. What's going on? You can see there's some stars there. And again, thanks to the bright porch lights of the museum, I got some very nice lighting on my foreground there, right? So later I went back and I looked up, what is this moonbow thing? I was like, oh, it's got a name. It's called a moonbow. So it's made just like a regular rainbow is, which a regular rainbow is generated when light goes through water droplets and goes through a process of reflection and refraction as shown over there. And it separates out into its constituent bands of color, right? But moonbows are much, much rarer because moonlight is way dimmer than sunlight. So moonlight, I just looked it up, I found some numbers there through various sources, and moonlight can be roughly 1 million times dimmer than sunlight, which means if you have to see a rainbow created by moonlight, you better be in a very, very dark sky. The other thing you need is you need a nearly full moon because it better be as bright as it possibly can be. And the third condition you need, I learned, was that the light needed to be only within a certain distance from the horizon. So it's perfect for a jet-lagged person in a rainforest at a near full moon in the rain, which it was raining. I don't know if you heard it over the roosters in that video, but it was actually raining and misting the whole time. This is how badly I want to see zodiacal light, apparently, right? So I went and I looked around a bit more, like, where do you find these moonbow things, right? And it turns out that anywhere you have big mists, and you have dark skies, and of course, the full moon, you're going to be likely to see moonbows. So that would be huge waterfalls, such as the Victoria Falls in Zambia. Yosemite actually advertises moonbows on their website. It's like, come to Yosemite and see a moonbow. Cloud forests of Costa Rica. And then I found one from New Zealand, which also has very dark skies. Okay. Interestingly, the Wikipedia article I was reading said, oh, big waterfalls such as Niagara Falls. And I was like, really? You're going to see moonbows in Niagara Falls? The other thing I learned is moonbows was so rare. When I went to my astrophotography community and I posted my moonbow pictures, I had friends who had been astronomers for decades who were like, I've never seen this. And clearly, if it would have been Niagara Falls, people would have seen this and gone to see it, right? So it turns out that, at least from some digging around online, the Niagara Falls used to have moonbows. But thanks to all the light pollution we have, if you've ever been to the area around Niagara Falls, you know what I'm talking about. These are much rarer, okay? And that's like an op-ed from our opinion piece in Toronto Star. Oh yeah, and so here we were with the moonbow and the setting sun was behind the camera. The other thing I got a double moonbow, right? You got the single rainbow here. Can you see my cursor? Oh, you can't see my cursor. Here, I've been moving my cursor all this time. So you get the what I hope you can see is that there's two rainbows. One's a brighter one, and then there's a dimmer one, and you can see the stars of Scorpius nearby, right? So again, this is formed exactly the way a regular rainbow is. Instead of having a single internal reflection, so in the primary bow section, you can see that the white light's going into the droplet and is reflecting once. For a double rainbow, it gets reflected twice. And the cool thing that happens is that the colors are flipped. So now you can see, I don't know how clear it is for you to see here, but you can see that for the primary rainbow, the colors start out being on the blue side and go through the yellows and greens and end up being red towards the top. But in the secondary rainbow, it starts out being red and goes all the way to being blue, which was kind of neat. And then a friend of mine told me there's a dark band in between. It's visibly dark, and it's called Alexander's dark band. So now we've got some names. And then, last gasp of the galactic core. You know, I was busy, like, what do I take pictures of? Oh, let's take pictures of the rainbow. Let's take pictures of this. And then suddenly the galactic core, despite what my PhotoPills app said, hung around till 5:49 a.m. and I was able to catch it. And those of you familiar with seeing it, at our latitudes will recognize some of the prominent features on there. I had some other adventures on my way back to the cabin, where there was a bit of a storm and a tree fell on the road. And maybe I can tell you guys about that another time. Did I mention there was no cell phone service? The second sort of unexpected fun thing happened when we went to visit this place called Polyhale State Beach, another place I recommend astronomers check out if you're going there. It's located on the western coast of Kaua'i, which will become relevant shortly. And it's supposed to have some spiritual significance as well to indigenous Hawaiians, because they believe that the soul's spiritual journey starts at Polyhale Beach, right? You are allowed to camp there overnight if you get a camping permit, and they're beautiful dark skies with sort of miles to look around. And I wish we had had dark skies. So we went there to just check it out and hang out during sunset. And here are some pictures. That's where the Napoli coast starts, and you've got the dunes and everything. But then I had my stellarium on me, or I looked on some astroforum, and people said, hey, Mercury and Venus are going to be next to each other tonight. So we had something else fun to do while waiting on the beautiful beach. And sure enough, as we were hanging out and we start to see dusk falling, we started to notice, again, I'm doing it with a cursor, but I hope, can you guys see the two dots up there? Don't worry, there's going to be a close-up in a sec. But there's a brighter dot, and there's a less bright dot to its left from where you're sitting. And the bright dot is Venus, and the bright dot to its left is Mercury. And remember, I told you Polyhale State Beach is on the western coast of Kaua'i. So we had just seen the sun go down, and it's the perfect place, perfect part of the sky to keep looking at if you want to see Mercury and Venus. And here is a zoomed in view of Mercury and Venus, and basically hung around there for 30 minutes trying to take just the right picture of this with the ocean waves and so forth. And again, if you just want to, go and confirm, you can either use a stellarium. It's a great app. Claudio had brought it up in his talk earlier to show you, to help you explore where in the sky objects of interest are going to be. And it's great because you can set, your place on Earth, and you can set your date and time. So I actually took the screenshot yesterday, and I said, set the location to be, somewhere in Hawaii, and set it to the date and time, and it shows it to you. So very handy tool, and there's like a phone app too, so you can just have it when you're traveling. And then we just sort of hung out. I'm pretty sure it's not that evident here, but even with a near full moon, the stars were so visible and beautiful. And all I could think of was, oh my goodness, can we keep staying here till moonset? But we couldn't because we had to go back to the cabins in the rainforest. So, but next time, if we ever go back, I'd like to sort of get a camping permit and stay here. And the third thing, of course, was a big thing that everybody was interested in around March break. And that was the total lunar eclipse we had. right? So for that, we decided to. So a thing to point out is that in Toronto, the total lunar eclipse was in the dead of night. It was somewhere between 1 o'clock and 2 o'clock in the morning, right? But I think we were like 6 hours behind. So for us, partial eclipse started around 7:30ish, and the total lunar eclipse was around 8:30ish, and then back to partial eclipse around 9:30ish. So dinner picnic, right, with the family, which turned out very nicely. So for this, we went along this beach, the set of beaches on the southern coast, which are lovely. And at the very south, there's the Poipu Beach, which is famous for the Hawaiian sea turtles that come out there every night to hang out. And it's just quite a sight. There's like a group of volunteers that comes in and just sort of keeps all the tourists at bay. And they have all these cones. You can see some of them. And the turtles, sometimes they're there during the day. Sometimes they'll just like swim up even as you're watching. And if you're snorkeling in the water, they'll like swim by you. So anyway, we went to a beach nearby Poipu for a little darker sky. And we just hung out and, started taking pictures. Sadly for us, we started having a lot of clouds go through during the eclipse. So, you can plan everything and then the clouds can come in, right? So, of course, because Murphy's Law, everything was perfectly clear through the partial eclipse. And then it was only around total eclipse that things started getting very kind of cloudy. So here is a picture of I don't know if you can see it from the size. I wanted to show you the partial eclipse with the beautiful ocean view and stuff. But you can see that the moon seems to have a little chunk taken out of it. Can you see that? The bottom right? It looks like somebody just cut the bottom corner of it. Wow. Let's see. Yeah, there's a tiny slice at the bottom. Maybe I can show it to you after or share it in some way. Oh, you could also look it up, images of partial eclipse, right? So, but we got totality and the clouds were going by and I was like, oh, you are looking over the Pacific Ocean, the Milky Way is right there. The total lunar eclipse is right there and you have all these clouds. And I could see Orion in the sky. And I said, let's just take a wide angle picture. And it is what it is. So this is the wide angle image. So for this, I took a DSLR camera with an extremely wide angle fisheye. So this is at least 140 degrees view or wider. And very, very kind of fast lens, means it sucks in a lot of light. And what you can see here is, the moon on the left, that teeny tiny glowing disk on the left is actually the eclipsed moon. And the point of it isn't just the eclipsed moon. The point of it is the sky with the eclipsed moon in context, right? So now you've got the moon, it's eclipsed, and that's why I can take a 13-second exposure with an f1.8. And on the right, you see a band of stars. Do you guys see that? Do you see the band of stars going up? And that's the Milky Way. I think I've got an annotated version coming up in a couple of slides. So I just wanted to oftentimes when we do these lunar eclipse images, we can either do the zoomed in view or the kind of composite, over time. This was my attempt at something, I don't know. And then again, towards the tail end of the eclipse, I was able to get a nice zoomed in view of the moon. And the other thing is, if you're by the ocean, it's very windy. And so there were times when I was just holding my tripod and I was like, gotta get that ocean shot with the moon. Photographers. Anyway, so this was in a quieter spot and there was partial eclipse. And so you can see that part of the moon is orange, but part of it is white again, right? So this is at the tail end of that. Oh, I don't have an annotated version. So I will go back here and point out that if you haven't noticed before, you can see Orion at the top right of the image. All right, so you can see Orion's belt, which is so if you guys see the top right of the image, you can see Orion's belt, which is a set of 3 stars going up, 1, 2, 3. And then you can see his sword, and then you can see his 2 kind of feet stars. So it's kind of a different way of looking at it. Yeah. So with that, I want to conclude the stargazing sort of travelogue and say that, here I started out thinking, you're going to this dark place during the full moon and, who knows, and I didn't even really take out my hardcore astro imaging gear for any of the photos. They said some of them, they just sort of like, you look on your app and you're like, what's happening over here? Oh, Mercury, Venus. And you just go enjoy it. I mean, the lunar eclipse was a bonus, right? And it was nice to be able to see it. But the moonbow was like so unexpected. And, sometimes when you're like, oh, what am I going to see? There's full moon, there's rain, and there's a dark sky. Well, you never know. You might see something completely unexpected like a moonbow. So it's sometimes you go and it's a miss. You don't see anything. But sometimes there's serendipity and you're gifted with something really beautiful. Yeah. And with that, I will wrap up and take any questions. Thank you.
Yes. We already got one question.
All right. We'll wait for the mic so the folks at home can hear you.
Were these chickens from more Polynesian ancestors, or are these from colonizers or indigenous Hawaiian people? Like, what happened? Why are there so many chickens all over Hawaii?
I think humans did
Or are
bring
they just
them.
invasive species?
Humans did bring them. My guess is in different waves because there's a mix of domestic and what's called jungle fowl, right? And so I think people just brought them over time and they've just interbred and they have different areas where you have different types of chickens. Yeah. I had a photo of a chicken crossing a road that I was going to put up for some pondering, but I was like, you have too many slides, cut it down. Yeah.
Okay. Any other questions from the audience?
Do you have one more question?
Oh, I just have a joke. Did it look like Crossy Road in real life?
Did it what?
Look like Crossy Road in real life?
I don't know who Crossy Road is.
A mobile game.
Oh,
Where
okay.
chickens cross the road.
Yeah, I wish I'd brought the photograph here now, so you could have answered that for me.
All right. Any questions online? No questions online? All right, then. So we're going to go. Thanks once again.
Great, thank you.
We're going to go once again to fun facts where we get our final speaker. All right, and our final speaker for the evening is going to be Frank Dempsey, who will be giving us an update on the star T Corona Borealis. Frank?
Okay, thanks, Tom. So I mentioned this, the star T Corona Borealis because it gained quite a lot of fame last year. A lot of you may have heard of it. In case you haven't, its fame was that it was predicted to erupt into a nova. And so, in case you're not familiar with a nova, it's where you look at a constellation. In fact, we have a picture here. Let's try right here. We'll see what happens. No, somewhere you have a constellation picture. Anyways, a star increases suddenly to magnitude 2. That was the prediction. And in general, a nova appears as a star where there wasn't a star before. So you're looking at a constellation, and you're familiar with it. In the case of Corona Borealis, it's this distinct round constellation, and all of a sudden there's a new star there. That's basically what a nova is. So it was big news last year. It was promoted as a blaze star, as one popular name for it. And so, as I mentioned, it was predicted by a lot of predictions to become a visible nova, increasing brightness to magnitude 2, which is a fairly bright star. And we're still waiting for it. And so a lot of predictions said last year is when it would erupt. And so I thought I would do a sort of a update on why it hasn't erupted yet, because a lot of people are wondering. And so a lot of, I noticed a lot of monthly presentations say, what's going on? We're still waiting for this star to erupt. And so to me, it's straightforward, but it may not be straightforward to a lot of people. So I thought I'd put in a few details here. A few pretty pictures too, because I don't like a slide full of text and nothing. So you'll see another image like that one. And so it is a picture of diagram of a cataclysmic variable star. And that's where we have two stars that are binary. That is to say, let me just say that most stars in our galaxy are binary. So many are single, like our sun, and many stars are binary, 2 or more together. And so in the case of a cataclysmic variable, it's a small white dwarf, which is a high gravity, low radius star, and in orbit with a larger star, in this case, a red giant. And the gravity difference sucks material off of the red giant onto the white dwarf, and eventually causes enough hydrogen to pile onto the white dwarf surface and cause a nuclear explosion, which causes the nova to brighten suddenly for a few days. That's basically what's going on. That's what a nova is. That's what was predicted to happen. So that's why the star is interesting, because it made fame last year and was predicted to erupt during the year 2024. And so there's a bit more details of why a nova occurs. And as I mentioned, there's a donor star and a white dwarf, and the mass piles off of the donor star, in the case of a red giant, onto an accretion disk around the white dwarf. So a white dwarf is a tiny dot. So it's basically the end life of a solar-sized star. Picture a dot the size of planet Earth containing the mass of the sun, or smaller. So it's a tiny dot within that big accretion disk. So the artist illustration in the prettier color picture gives a better illustration, I think. So mass pouring off of the donor star into the accretion disk around the white dwarf. And as I mentioned, eventually causes a thermonuclear explosion on the surface of the white dwarf or the accretion disk. So let's see. It's worthwhile to point out that there are only 4 known stars in our galaxy with a red giant donor. There are more recurrent novae, that is to say, they recur every X number of years. In the case of T Corona Borealis, it's predicted to recur every 80 years. And so last time it was seen to erupt was year 1946. And last time before that, year 1866. So it's considered to have, I was told not to move around in front of the microphone too much, so hopefully you can still hear me. But the point was, it's considered to have an 80-year recurrent cycle. So there are only 4 stars known to have a red giant donor star in the Milky Way. But I put in a picture of the Milky Way to say that there's a heck of a lot of stars and a huge amount of universe we don't know about. So we know about some of those stars. We know of 4 that are recurrent novae, but there's a huge amount of our universe that we don't know about. So just wanted to put that into perspective, mainly for my own amusement. The Corona Borealis, I may have mentioned, it's a fairly popular constellation. If you can see if I can get control of this, maybe not. To the right. So anyway, yeah, so you see a crown-shaped constellation here, and it's basically overhead right about now. It's very high in our southern sky right now. If there were no clouds, you'd see it tonight. And so brightest star is fairly visible. I can see it from my light polluted sky in Pickering, and can't really see many other stars except on a very clear night. But A second magnitude star, if it erupts, if and when it erupts, would be visible right about here. This is the location of it. And so it would really stand out in this otherwise familiar looking constellation. So that was one reason why I had some excitement predicted about it last year. So Corona Borealis, distinct constellation, and it's fairly high in our southern sky right now. And if it were to erupt anytime soon, Claudio pointed out that there are already currently two visible novae in the sky, although in the southern sky. And if T Corona Borealis were to erupt tonight or during the next few days, we'd have 3 naked eye nova in the sky, which would be quite rare. Anyway, let's move on. I need to explain this. I'm going to point out some details about a light curve, so you may or may not be familiar with a light curve. So I'm going to point out some details here that are sort of relevant. I'm starting off with a fairly common star that I look at often called V Bootis. So the point of a light curve is that plots magnitude or brightness on the vertical axis and time on the horizontal axis. So you see going forward in time, it becomes brighter and fainter and brighter and fainter. This star is interesting because it's not always perfectly regular. It's not perfectly sinusoidal patterns. Say here's an increase here and not in this cycle, and what's going on. And so the other detail I want to point out here that the way this plots, this is the AVSO website plotter. Thousands of variable stars can be plotted, but the point here is that the circles are visual observations. So people like me that look through a telescope and estimate the brightness and submit it online contributes these black circles. So a lot of the other observations are photometric, and that's where thousands of people and small observatories do photometry, where they have automatic setups to monitor various stars every night and cause these green dots. So in some cases, they're more reliable or more precise than visual observations. In some cases, they're not. So here's an example right here. Say, what's going on here? The photometer, photometric observation here, picture that. Is it real? We don't know, because a lot of these observations are automatically without the observer or a person in charge of the observatory even looking at the sky. They can be done overnight during a whole long sequence when somebody's sleeping and not even paying attention. So were there clouds? Was there a forest fire smoke? Who knows? At least myself, when I do these visual observations, I don't do it if there's questionable conditions. Take your pick: wildfire, smoke, aurora, so on, that can interfere with the quality of the observation. So I don't want to be known for sloppy observations like these, whatever they are, or possibly these ones. Are they real? Don't know. So the AVSO encourages good practice and observers, and not everybody follows them precisely, but that's the light curve. So that's Victor or VBOO. Here's another example I was observing recently, and I put this in to illustrate that it's quite a bit more sparse. It's way down in the constellation Scorpius. It's only visible above our southern horizon for about a month during the summertime. It's really hard to observe, but I got one of these observations is mine, and you see it's trickier and it's even out of balance for a lot of photometrists. So a lot of the automatic photometry setups don't even try it because it's so far south. But being an extreme location, like in my case, way down in the southern horizon, I can do it with a telescope and I can come up with reliable observations, and so do many other observers. But you see it's quite a bit more sparse. So that's another example of a light curve. So on to T Corona Borealis. So we plot all the observations for the past year. You may see there's not much happening. You may see it's around 10 to 10.5 magnitude. And say, oh, that's pretty faint. In case you're not aware, roughly 5th magnitude and brighter is approximately naked eye brightness. So the brightest star, in Corona Borealis is around roughly 3rd magnitude. If T Corona Borealis erupts into a nova, it'll be around 2nd magnitude up about here. So see, in the past year, it's generally hanging around 10.5 magnitude. So that's fine. That's what's been happening for the past year. Look at the past 5 years. It starts to pick out some little sort of sinusoidal activity going on there since approximately the past 5 years. But otherwise, no big eruption. Past 25 years, again, see nothing much happening. You can microanalyze it and pick out some details, and I'll point out this increase since approximately 2016. Later, I'll mention that again. But otherwise, you can say, hey, there's no eruption, pretty darn boring. Why does anybody look at it? So, okay, let's go on to some other details. So the The update I'm sharing with you is some work by some astronomers in this recent paper. So that's what I'm going to talk about from now on. And so you can access it, open access, and either of these links here. All these authors did the work on it. So I'm just sharing with you the work that these guys did and I read about last approximately May. So I think it's worthwhile to mention because a lot of people are still yelling, why is T Corona Borealis has not erupted yet? And it was predicted to erupt last year. So I'm presenting these guys' work from now on. So here's a graph from their paper for quite a few years, since approximately year 2007. The V band, I'm going to mention also V band and B band. So V as in visual band, approximately green, is done with a filter that's approximately green color and approximately visualizes what we see with an eye in visual band, a visual wavelength. So that's what the green filter is. Blue filter, blue photometry shows more energetic processes. So I'm going to show you blue and V photometry. There's also red and infrared photometry done too. I'm not going to mention them too much. Let's see. Brightness data from the year 1866. So I mentioned that there was an eruption in 1866 of the nova. And here you see it claimed to be second magnitude. I don't think there were a huge amount of observers around that year, but there were more in 1946. It's just funny to mention that 1946 was reported by a 15-year-old boy in Wales, a Welsh boy who saw it and thought, that's pretty darn weird. So he sent a letter to the Astronomer Royal. And so it became accepted that, that's an outburst of this star T Corona Borealis, and it must be a recurrent nova. And so another detail to point out is that in V band brightnesses, it shows more detail than the visual. So the B band, or blue, I'll call it, shows an increase before the eruption. So several years before the eruption, the star got brighter. It's less visible in the V band, or I should say visual, because B and V sound similar. So anyway, I'm pointing out that pre-eruption increase. Okay, so why was it predicted to erupt during 2024? Because I mentioned that this pre-eruption increase in brightness was observed before the 1946 eruption. That was the one I just showed you at the bottom. And it was followed by a dip in brightness shortly before that eruption. Maybe if I go back to it, I can point out again, it shows up a little bit right here. You see an increase in brightness before the 1946 eruption. That's a pre-eruption increase, and then it dipped in brightness, and then it erupted. So that's what's was analyzed last year. So so that was the basis for the prediction last year, that this was seen again. So what the authors of the paper did is overlap some data. So the data around 1946 eruption is in dark blue. So you can distinguish that from the lighter blue, which is more recent data. So when they overlap the data, you can see that there's also this pre-eruption increase occurring in the recent data. And so followed by a dip. And that was why the authors of the papers forecasting an eruption last year said it's about to erupt for that reason, because the light curve matches what happened 80 years ago. Okay, so that was a basis for the prediction for the eruption in 2024. So we know it didn't happen. But the V band brightness data are different, and this is significant. So you look here and see this is the 1946 data, the V band or visual band photometry data also dipped in brightness shortly before the eruption, but the current recent data don't do that. So similar superimposition of the 1946 data here with the recent data shows us a difference. So it means that the simple model where the blue band data predicted the increase, your actual star model data is more complicated than that. So I should say, I mentioned this already. So the brightening, pre-eruption brightening is indicated by this brighter data here. So there's mass accretion onto the disk, the accretion disk surrounding the star. So I mentioned this. There's also some recent data, which I'm not going to mention, about Balmer lines of hydrogen 1 and He2. So it's considered that most of the pre-ignition mass is likely accumulated already onto that accretion disk surrounding the white dwarf. And so this is current data. And so it's, as I mentioned, the V band or visual band data doesn't match the blue band data. So the actual mechanics and physics of a star and eruption are more complicated than thought earlier. So there's a lot of complexities involved here. And when you're talking about accretion disks, there's a whole lot of details that can get in the way. So I'm not going to read this list. I would only say that if you think any of these are interesting and these details that affect the accretion disk, take your pick. Magnetic fields, dust shell around the star, and instabilities in that accretion disk and so on, how they affect the eruption of a cataclysmic variable. If you think they're interesting, I recommend you study up on them, read about them. If you want, put together a 15-minute presentation and stand here and tell us about it, because it's really darn interesting. But I'm slightly prejudiced because I've been looking at variable stars for half a century, and I think all these details are interesting. Everybody should find this really interesting. So I'm a little bit prejudiced. So there are a lot of details here. In case you want to look into it, you can. But the main point is it's a lot of details that make the eruption of a cataclysmic variable more complicated than the model that was used to predict the 2024 eruption. So in conclusion, the pre-eruption dip does not really predict an eruption. It's more complicated than that. It's more complex than first modeled. And also, it's worthwhile to point out, as I mentioned, the white dwarf has been accumulating a lot of mass recently, so an eruption is imminent. And I should point out again that 80 years, if it's an 80-year cycle, from 1946 is 2026. That's next year. So an eruption is imminent. Yes, the light curve data show that something's happening and mass is accumulating onto that accretion disk. So imminent, does that mean this year or next year? I'm not telling you, but I want to finish off with one other detail in case you get so excited that you want to observe the star in case you're not already observing it. And so can you observe it? Should you even bother to do that? So here's this plot I put together for the last 5 days. I put this together yesterday, so it's past 5 days approximately. So once again, the visual data, mine are in here. I probably did 3 observations in the past 5 days, roughly, including last night. So these black circles are visual observers' data, making observation with a telescope and submitting it online. But you see, it's vastly outnumbered by the photometry. So all automatic photoelectric and photometric observatories, people have their cameras, CCD cameras, and so on, doing photometry and automatically sending in data and vastly outnumber the visual data. So should you even bother wasting your time? Maybe. It'll just be neat to see. So I'm finishing off with this one. One reason why you might want to pay attention around November is because solar conjunction occurs when Corona Borealis dips toward the western horizon, very close to the sun, and then photometry drops off and the visual observers drop off. And so around November, this is picture from light curve from September last year until May this year. And around November, observations become sparse because it becomes very difficult to observe it. So maybe observers on higher northern latitudes or farther southern latitudes have a better perspective on it and better weather than we have in the Great Lakes area. But around January, it starts to reappear in the morning sky, the pre-dawn sky. And so that's when I started picking it up, and you see the observations pick up then. So if you were to get used to visually observing this star now and become familiar with it, and every time you look at it, it only takes 5 minutes once you're familiar with it. Your observations might be really valuable around November, around this period when observations drop off. And you can also see that the photometry drops off too during that period, becomes less dense. So I don't know about these guys, where they were and so on. You can look it up. I can look up each observation if I want to, but I'd say I don't know how accurate these are when someone has an automatic telescope pointing toward, almost to the sun, toward Corona Borealis in November, but data are there. And so I'm just saying that if you wanted to observe the star around solar conjunction, your data could be really valuable. Okay, clear skies, happy observing. I just wanted to finish off one little picture. You need a really fancy telescope to observe it? No, it's 10th magnitude. There's a little telescope. That's fine to look at 10th magnitude star. You don't need much of a telescope. Anyway, that's all I wanted to share with you. Tom asked for any presentations. I thought this might be relevant because a lot of people are saying what happened here. If you want to start to observe variable stars, great resource here with the AAVSO website. And I would say happy observing if you decide to do that. Okay, thanks for your time.
Thank you very much, Frank. Any questions from the audience? Okay.
Was T Corona Borealis known to erupt before the 18 whatever? Because I would say magnitude 2 is going to be pretty obvious to anyone looking at the sky.
Yes, interesting question, because there actually were several observations that the astronomer who put that together, Brad, what's his name, in Louisiana, dug up some observations from as far back as the 1860s and claimed that those observations in the 1860s also recorded at nova. As far back as that. Do I believe it? Maybe. I haven't looked at the references, but it's quite possible because well, the question is for that astronomer who had that paper and made those predictions, he published what he thought were reliable observations, reliable data. Yeah, reliable enough to put in his paper. I would say, if you're asking, did people see it before that and recognize it and say, hey, something wrong? Yes. So what about all the First Nations people across Northern Ontario said, hey, that's really weird. That's really strange. What about people worldwide who could see Corona Borealis and say, wow, that's a really distinct constellation, something going on there? Yes, very likely, because people knew the stars in the sky like the back of their hand. Before, say, a few hundred years ago, people lived by the stars. It was their calendar, it was their agricultural details, whole pile of details why they recognized all the constellations, and they saw really faint stars in the sky because there was no light pollution. Maybe their local campfire or whatever, but they were familiar with a lot of faint stars, and when they saw something that really disrupted that familiar looking constellation, I would guess, to answer your question, probably thousands of people saw it, maybe millions of people saw it hundreds of years ago, yes. But it would surprise me if there were any reliable observations. And so Brad, I forgot his name offhand, did publish some that he thought were reliable enough to publish as data from as far back as 1200 something, and several between then and now. So reliable data that constitute an observation is different from thousands of people. I'm speculating that thousands of people saw it, just like pick any comet that occurred then, or numerous eclipses and so on. Of course, thousands or millions of people around the world saw each of those events, but they didn't necessarily record it. So big difference between recording an observation and seeing it.
I'm just going to jut in here then and with point out 80 years before 1860 is the 1780s, which means William Herschel is poking around in the sky with his telescope at the time. So somebody's got to have recorded it in the 1780s if it did go off.
Yes, let me point out one crucial detail why we might miss it if it erupts tonight or the next few days. Not just for Britain or Great Britain or England or whatever you want to call it, but if the weather is cloudy for a few days, we might miss it because it will erupt. It's predicted to erupt in hours to maximum brightness around second magnitude, and then drop off, maybe be naked eye visibility for approximately a week. And so if it's cloudy during that week, we're not going to see it. Somebody across North America will have clear skies, yes, and it'll make news, and there'll be noise around the world, and people around North America that have Corona Borealis above the horizon will be rushing to see it. There'll be photographs on, take your pick, YouTube, et cetera, et cetera, et cetera. But anybody like we here could be under cloud for a week. We could be under wildfire. Don't want to talk about these evil things that could occur, so I don't want to mention too much noise about them. But there are lots of reasons why a guy in Britain at the wrong season of the year could have missed it.
Fair enough.
Just a trivial question. Can you go back a bunch of slides, please?
Okay,
There's
a
slide
bunch.
with error bars in it. Another one. Go back again.
Error bars.
Go back again. Go back again. Keep going. No, go forward, please. Slowly.
Sounds like you saw an intriguing picture that had a lot of details which I didn't mention.
Yeah, wait. Keep going. Keep going. Keep going. There. These error bars here. What's the data that causes the error bar? That's one question. And can you explain the pre-ignition dip and the pre-eruption dip and the pre-ignition mass accumulating on the disk?
Let me start with the pre-eruption dip. No, I can't. It's a complicated physical. Anybody in the room know? I don't. It's complicated physics detail which I didn't pay attention to. Anybody want to contribute? Dust formation. Good point. Thank you. Dust formation causes a pre-eruption dip. Because I may have mentioned that the whole system is more complicated by a dust shell around the whole system. In a lot of cases of cataclysmic variables. So you asked about, that's the pre-eruption dip in brightness. The pre-eruption increase in brightness is caused by mass piling onto the accretion disk. So in general, we see the star's brightness. It's a combination of the donor star, in this case, the red giant, the white dwarf, maybe, and the accretion disk. And so the accretion disk is brighter with more mass piled onto it.
What causes the error bars in the green?
Many authors of the paper scrounged up data. This is from before 1946. So they scrounged up data from old photographic plates, various records that were around. I guarantee you in 1946, there were not a lot of people with backyard photometers.
Right, but the error bar goes from 9 to 9.1 and then below to 10.9 or something like that.
Yep.
In the first instance.
Yep.
So that's pretty large.
Well, so the point about the data before 1946, this pre-1946 data were scrounged from numerous photographic plates, numerous data sources existed around the world in libraries and plate libraries and so on. And so people scrounge out to find those scrounge to find the brightness of that star, and they do this all the time for various things that erupt into whatever. But it means that somebody made some estimate from that photographic plate. Yeah, okay. It's an estimate, and they made some estimate of the error, and that's where the error bars come from.
Okay. Thank you.
How many light years away is a star?
If I vaguely remember, it's very roughly 200 to 300 light years away. So I didn't put that on. I left off a lot of physical details, which I know are interesting, but I cut a whole pile of stuff off to try to make it as relevant as possible. So could just generally say it's several hundred light years away.
I was simply curious. Also, can the accretion disk from type 2, is this a type 2 supernova?
No, it's not a supernova. So let me briefly explain some details of a white dwarf. A solar mass star like the sun is predicted to eventually become a white dwarf. And so it reaches a certain phase in its life where it starts to contract and gravity takes over and compresses into a white dwarf. A hugely massive star, say 30 solar masses, has enough mass to erupt into or to end its life as a supernova. But a white dwarf is too low mass. It began as an approximately solar mass star, so it's not massive enough to become a supernova.
Though I wasn't quite asking that, I get what you mean.
Okay.
Also, can the accretion disk form stars and become a nebula, or does a star have to explode before the nebula forms that becomes new stars, if that's possible?
In general, no. The accretion disk does not cause nebulas. Nebulas come from expanding shells of gas puffed off by the star. Somebody, Claudio mentioned Wolf-Rayet stars, which are one of the stars known to have strong winds blasting material off them. And so they cause a shell of gas and dust expanding in space, which we never know about until they get illuminated by a shock wave crashing into them generally. But an accretion disk is different. It's just mass being pulled off of the donor star, a red giant, swirling around the white dwarf because of its strong gravity, and eventually funneling onto the white dwarf. So it's a very separate, different thing from a nebula.
Cool. Yep. Can a similar process happen with black holes?
No, a black hole. Why don't you hand the microphone back to help me out, because a black hole is a very different process. Do you want to sum it up?
The central masses, they're all referred to as compact objects. and any compact object can write one with a source of external source of material can produce an accretion disk. So if you recall the photo, quote unquote, photo of Sagittarius A, or of the event horizon photo of M81,
87.
M87, sorry. Those are actually images of the accretion disk around the black hole that you're actually seeing there.
I'll just make a quick comment that it's T Corona Borealis is probably a good ways away, because if you estimate a red giant is pretty bright, so for it to be 10th magnitude, I mean, it might be 1,000 light years away. I don't know, but you could estimate it from the star's type and how bright we know the star to be.
Well,
Wikipedia says 3,000. Google knows all.
okay, I wouldn't argue, because I decided it's not a hugely relevant detail to put in the presentation to add more technical detail. But the point is, it's far enough away that we can't aim a Hubble Space Telescope at it and get separate. We can't separate it. It's too far away. So it's not totally relevant. It's just far enough away.
And we're getting kind of late, so I'm going to call the questions right now. Frank, thank you very much. And we're going to have a brief flip over to announcements. All right, and so let's wrap things up with the evening's announcements. So I want to thank you all for taking part tonight. What you've just seen is one of our recreational astronomy nights, which we host both here in person at York University and live on YouTube. And thank you very much to our folks joining us live on YouTube. And then we have speaker nights, which are currently off for the summer season, but they would happen 2 weeks after the recreational astronomy night, and those are online only. It allows us to bring in speakers from all across the world, rather than just within the Toronto area. So for those of you joining us live on YouTube, please ask some questions of the presenters using the chat function. And if you are a new member, introduce yourself and tell us where you're coming from. So our next recreational astronomy night is August 6th, right here at York University. The sky this month, the presenter we're still looking for. Dennis Gray will be giving a talk on asteroid in action. This is an asteroid occultation. And then we currently have one empty spot. If you'd like to present something, give me a shout. After our monthly recreational astronomy nights, we've got public stargazing going on the Arboretum parking garage. We've got a bunch of telescopes set up, and there will be set up after the meeting, assuming it hasn't clouded over and it's not pouring rain. Now, during the summer months, the Carswell Observatory, which is just down the hall from us, offers observatory tours. on third floor of the Petrie Science and Engineering Building in room 317. In the summer months, the telescopes are open after the RAN, and in order to do some actual observing, if you'd like to, you can book tickets at the observatory website as shown here. And as again, like I said, we will have telescopes set up on top of the Arboretum parking garage after the show. So what's coming up at the DDO, the David Dunlop Observatory, in the next few weeks? The first clear night of July 7th, 8th, 9th, 10th, or 11th, starting at sunset, is a stargazing night. Bring your own binoculars. This is a free event. Just come on into the site. So it's first clear night. So if July 7th is clear, the event will go ahead, but that means that's the one and only. Then coming up on Saturday, July 12th is DDO Astronomy Family Night. Comet Collision Course, when Shoemaker Levy 9 hit Jupiter. Yeah, that was 30 years ago. Registration can be done online. Fees are as shown here, and the links to register are on our website, rastio.ca. Then coming up on July 26th, 9:30 to 11:30 p.m., Perseids, Warm Nights Shooting Stars. Again, you can register online, and the links can be found at rastio.ca. July 27th is Sunday sun gazing from 12:30 p.m. to 1:30 p.m. Fees, again, as shown here, and you can, you register online with the links on our website. Sorry, the mouse is misbehaving. Okay, and our next Recreational Astronomy night is late enough in August that some events actually start happening for next month. So on August the 2nd is DDO Family Night. Happy birthday, Helen Sawyer Hogg. And again, registration fees as shown here. Register online at the links at our website. And then the August stargazing night is the first clear night of August 4th to the 7th, starting at sunset. Again, free event, and bring your own binoculars. Now, coming up in Millennium Square, free public star party, July 4th or 5th from 7 p.m. to midnight, weather depending. Join us for an evening of free public stargazing on the North Shore of Lake Ontario, Millennium Square. We start out at 7 when the sun is still up, and you get a chance to look at the sun through some silver telescopes, see what's currently going on, any sunspots and prominences. And then as the sun goes down, you get a chance to observe the moon, take a look at some of the stars through our telescopes, check out the astronomy literature we have at the booth, ask some questions, and if you have your own telescope, you can bring it along and we'll help you point it at the moon. Reminder that it's cooler down by the lake, and to check our website for a go, no-go decision based on the weather before heading down to the square. And then also Millennium Square is free solar observing, July 12th from 10 a.m. to 1 p.m. Again, come on down and take a look at the sun through filtered telescopes. Again, go, no-go decision on our website. Whoops, gotta go back one. Come on. There we go. And the August Millennium Square Star Party is August 1st or 2nd, weather depending. Same sales pitch as before. But again, check our website for a go, no-go decision. Coming up at the end of July is the Toronto Centre's City Star Party at Bayview Village Park for Toronto Centre members only. The first clear night, Monday, Tuesday, or Thursday, July 28th to the 31st. So skipping Wednesday. Again, please check our website for a go, no-go decision. I'd like to invite you all to the 2025 Open House and Awards Picnic at the Carr Astronomical Observatory near Collingwood on Saturday, July 26th. Our club observatory on Blue Mountain will have the Toronto Centre Awards presentations. There'll be some observatory tours and nature hike. We'll be launching some rockets, and hopefully they'll come back down. There'll be a barbecue potluck dinner and more. It's open to members and their families. The event is rain or shine. Please cross your fingers. We've had some fairly heavy downpours recently, and we would not like to repeat that. Booking for overnight stays in the house or camping on the site is now available via the RASCTO website. Login is required. And for times other than the open house, access to the CAO is available year-round. Masking on site is optional. And please see this online CAO bookings page for details at the link provided. This is where I get the plug RASC membership. If you have enjoyed what you've been seeing this evening and would like to be a part of the RASC Toronto Centre, you can sign up online at secure.rasc.ca, or you can renew your membership. And gift memberships are also available from the national office. Contact mempub@rasc.ca for more info. The Toronto Centre runs on clean, renewable, volunteer energy. If you're a RASC Toronto Centre member and you're interested in helping, you've got some free time, we'd love to hear from you. Everything that's being done here is done by volunteers. Please contact the volunteer coordination team, volunteer@rascto.ca. The meeting after the RAN meeting, afterwards we adjourn to the VMV's Bar and Grill, which is just southeast of the university on Keele Street. There's free parking. Yeah, some people call it a more important meeting, but that's their opinion. And a couple other minor announcements. We have a whole bunch of stickers you can grab on your way out. If you are one of the members who signed up to get your own membership badge, I have them. Please see me. And for everyone else, have a wonderful evening. Thank you very much for joining us. Please follow us on all the forms of social media we've got listed here. Be safe and keep looking up. Good night, everybody.